Hello. And I am recording. I have 6 o'clock. Just turned on the recorder. Let me double check and make sure everything is up and running. Testing the speaker. Yes, testing. Everything appears to be good. I am recording. Okay. Today is Thursday, June 20th, 2019. This is the scheduled meeting of ITSC 2309 SQL programming at Collin College. And let's see, there will be 2 recordings done tonight. I'm going to do a full recording, and then I'm going to come back and do a very quick wrap up of it tonight. So I'm making some changes tonight. So the first recording is going to be the full recording. It'll be roughly 50 minutes or so. Let's see, we've been working with a select from where statements. And if we were to work with some of them, excuse me, I need to back up here. Let me get to the, get to the initial page of Module 6. So tonight we are in Module 6, and we are talking about joining tables. The first one, joining tables, I refer you to Dr. King's video on joining tables. It is fairly good and all of that. Okay, let me make sure that I'm recording. Let's see, I see Larry present. Larry, can you hear me? Can you speak? I think that I have a chat. Okay, I see a yes in the chat. Okay, that's fine. Yeah, chat works pretty well. I encourage you to view Dr. King's video. And with that, I'm going to move on. It's I'm not going to play it here. Reading assignment is given here, and this is what we will cover. So you really need to read this textbook assignment. It is fairly good. I'm going to create a table. May I create a table, please? Of course I can. Parent. My table is named parent. Parent is the parent table. It has a PID, the parent ID. It is char1. That's the primary key. So it is just a table with one field, and that one field is one letter. And I think I put, what did I put in there? A, B, and C in there. Create a table. The table is named child. The child has a child ID, and the child has a parent ID. The child ID is a primary key. The parent ID, PID, is a foreign key that references parents. I insert into the parents values A, B, C. I insert into the child values X. The child X has parent A. I think it would be better if I went over here. Insert into parent A, B, and C. I'll give you this file, A, B, and C. Close this. Now, insert into parent A, B, C, insert into child. So in the child X has parent A. Child Y also has parent A. So parent A has two children, X and Y. Parent B has child Z. Now I'm inserting into a child Q, which I don't think I have in the other file. Q does not have a parent. Q is an orphan. Q is an orphan. It does not have a parent. I'm inserting a null value into the parent. So, okay, are we fairly clear on that? So I have parents, A, B, and C. I have child X, Y, Z, and Q. Child X has parent A. Child Y also has parent A. Child Z has parent B. And child Q does not have a parent. What about parent Z? Parent Z does not have any children. Okay, that's two important points there. Okay, and so now if I execute this guy, so use Scratch. I'm using Scratch because I'm just playing around with it here. I have my object. If object ID child is not null, drop table child. If object ID parent is not null, drop table parent. So I drop the child first, the parent second in good order. Then I create the parent. I really should have, I didn't put it here, I really should have a go here. And I really should have a go between them. Sometimes it'll let you get away without it, and I should have a go after them. So this is in good keeping with this. So if I execute my stuff now, I'm going to start here, and I'm going to execute, down to the select. How about to about right here? I say I'm going to execute this guy, execute Q. Okay, what's my problem? I don't have a comma. I'm missing a comma. So it tells me right quickly when I don't have something. Happens to me too. Execute, everything's fine. So what did I do? I created these guys. And if I wanted to look at them, I could. If I said select everything from child, I would see X, A, Y, A, Z, B, and Q null. And that means that X, we'll take a look at that. Select everything from, let's look at parent first. I said select everything from parent. Doesn't matter whether you're in uppercase or lowercase. A, B, and C. Select everything from child. Oh, why? And now I see Q, null. It does, don't worry about the order of it. Order just happens. It's ordered by the primary key. Primary key is CID, so these are going to be in order. We pretend that we don't know that, but we do know that. That's the way it's going to work. So the primary key will always be the ordering if you don't say otherwise. So Q has no parent. X has parent A, Y has parent A, Z has parent B. So we have two siblings. X and Y both have the same parent, and Z has a parent. C, the parent C has no children, and that's it happens that way. So what would happen if I said select parent child, and let's see, select parent PID, child PID, and the child ID. Now, I had to say the parent.pid and I had to say child.pid because they have the same name of the field. So if I had not specified the table name, I would have gotten an ambiguous column because I can't just have I can't just say PID. That's not going to work. If I try to do that, I get ambiguous column name. So the PID appears in both of them. And since it does, I have to specify the table name. So I want the parent PID. Remember the parent PID, that's ABC. And I want the child PID. The child PID is XYZ. Oh, Q's there too. And I want the child's ID. I don't have to specify the table name for the CID because that only appears in one. From, this is important, parent, comma, child. So I'm putting them both together there. So let's see what I get here. Now, what did I get? Oh my goodness, I got a lot of stuff here. I got 12 columns. So I got A, B, 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 C, 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 Q, X, Y, Z, Q, X, Y, Z, Q, X, Y, Z. In other words, I got A paired every possible way with the child ID. I got the parent ID B paired every possible way with the child ID, and similarly with C. Okay, now this gives me every possible pairing. So when I just say parent, comma, child, I get every possible pairing, and this is what is called a cross join or a Cartesian product, many people will call it. Every possible way you can put the stupid tables together. Questions? Now, most of the time we will write it something like this. We will rename things. We will name it primary key and foreign key. So I'm choosing to name the PID. But here's the important thing. I really don't feel like retyping the parent and the child all over again. So I'm going to alias the table parent, and I'm going to alias the table child as C. So P will be the new name for parent, C will be the new name for child. So I want P.PID, and I want that named primary key. I want the C.PID, I want that named foreign key, and then CID. I guess I could name that anything I want. So when I execute this, I'm going to see the same data, but it's named differently. The primary key is A, B, and C. Foreign key is null, A, B, null, A, B, null, A, B, and there's the child ID. Now, which ones am I really interested in? I am only interested in those areas where the primary key and the foreign key are the same. For example, where the primary key and the foreign key are the same. So I'm interested in this one, A, X is my child. Interested in this one, A, Y is my child. I'm not interested in A, B, that's not me. B, null, nope. B, A, no. B, A, oh, look, here's another one. B, B, Z. C, no, nope. C, nope, nope, nope. C doesn't have any children, not interested in them. So what am I interested in here? I am interested only in this one. Select PID as primary key. So I've given it, I've renamed it here, and that's fine. I didn't have to. Didn't have to rename the table as P and C. I just don't like typing. Select C.PID as foreign key. I renamed it. I could have named it child.PID, would have been fine. And finally, CID. From parent as P, child as C. Oh, here's the important piece of it right there. Where the parent ID is equal to the child ID. And the order here is not really apart. The order is only here just to be consistent. So I'm ordering it to where I'll get something going. Now we see my parents and my children. For primary key A, foreign key A, child is named X. So primary key A has a child X. Primary key A has a child named Y. Primary key B has a child named Z. Well, but what about the primary key AB? What about C? What about the parent named C? The parent named C does not appear in this join. Why? The parent named C has no children. This kind of a join only shows parents and children who participate in the relationship. Important point here. This is called an inner join. It only shows parents and children who participate. What about the child that was an orphan? The orphans do not participate in the relationship. Orphans do not have parents. Therefore, this condition by which they appear in here, where the parent is equal to the child, if it's an orphan, that condition never goes to true. So the orphan never appears. Childless parents and orphans will not appear in this kind of a join. Important point. Childless parents and orphans do not appear in this kind of a join. Questions? Pausing briefly. Now, this was the way we did it for a long time. So this is the join. If I say parent, comma, child, where the primary key of the parent equals the foreign key of the child, it will virtually always be the same, be the primary key and the foreign key. I can't think of any that we're going to do that aren't primary key, foreign key relationships, although I think there might be one coming in there where it isn't. When you do a table join, it is virtually always where the primary key is equal to a foreign key. If I said always, I'd be wrong because it isn't always. But for right now, for learning it, it is always. So when I just say from parent, comma, child, like this, I'm going to get everything. And then the where clause narrows it down and says, I only want those where the parent primary key is equal to the child foreign key. Now, this is called an implicit join. This is the way we did a join, back in the days when I had to walk to school 2 miles through the snow. Oh my goodness. And this was just how we did it. And I'm going to talk more. We're going to have it. It is possible to have a three-way join. So I can have a parent, comma, parent P, comma, child, C, comma, grandchild as G, I guess. So I can have it go as far as I want to here. I can join as many of them as I want. If I stopped right here, if this was all I did, okay, how many do I have in parents? I think I have what? I have 1, 2, 3 parents, and I have 4 children. I'm going to get 12 records. So if this is all I execute, let's try it, execute, and let's notice how many records I get. I believe I'm going to get 12. 1, 2, 3, 4, 12. So A, B, 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 C, 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 C. So I get every possible joining of A with every possible foreign key. A joins with Q, A joins with X, A joins with Y, A joins with Z, B, Q, X, Y, Z. C, every possible joining. So I have 12 possible joins. But of those, I'm only interested in just the ones where the primary key is equal to the foreign key. Does that make sense? So once I throw that in there, now I have narrowed it down to where I get the primary key A has child X, and I probably wouldn't show the foreign key. Primary key and foreign key will always be the same. Primary key joins with foreign key X. Primary key A joins with foreign key Y. So primary key A has 2 children. Primary key B has 1 child. Primary key C doesn't have any children. Why? Because there is no place in there where C has a child. No child has foreign key C, but foreign key C could have a child if I added him to the, if I added this insert into child, if I added C, A, B, X, Y. So parent C, X, Y, Z, if let's see, what would that be? W, child W could have parent C. And in that case, child W would have parent C would have a child. But I get a child because he appears in the child table. In this case, it doesn't have any. Okay. The new way that we do that. Now, new rules. I'm going to pause for just a second here. Anybody can speak that needs to speak now. You're able to unmute and speak. Okay, I'll assume that everybody's happy. Okay, this is the new way. Back in about mid-1990s, we got away from this method of doing it. Now, this method works just fine. This is called the implicit join. And that is where you just say from parent, comma, child, and then you do the join in the where clause. Yes, and that works just fine. This is the new way. Okay, the new way says, well, the select is the same. Select, and I've chosen to rename them the same. I've kept the select statement exactly the same. Primary key, foreign key. Okay, here's where it gets different. From parent as P, same here. Inner join inner join, child as C, on. Okay, so here we've, instead of being in the from, I've got it in the from parent as P, but instead I picked up the word inner join between them, and I pick, instead of where, I picked up an on in here, so it's changed slightly. Now this will be, these two are exactly the same. If I run them, they will always give me exactly the same output. So parent A has child X, A has child Y, B has child Z. They always give me the same output. Yeah. But this is the inner join. Now, on this syntax, you will see people who will drop the word inner. And it is possible to write this syntax as just simply from parent P, parent as P, join child as C. This will work, but I want you to write the full syntax while we are here. Okay, I want you to write it from parent as P if you rename it. Now this part of it, renaming the parent as P, is optional. You do not have to rename the parent as P. If you do not rename the parent as P, then down here where you say P, you have to type out parent, P-A-R-E-N-T. Down here where you say order by, you have to type out P-A-R-E-N-T. Down here where you say inner join child as C, you could just say child and you could drop this. But then when you wanted to say C down here, you have to type out C-H-I-L-D, because the field name for both of these is the same. Now, I think it is a good idea to keep those field names the same. Some people don't. Some people would argue with me there. That's fine. They can argue with me. But I keep them the same. Oh, let's see. The parent ID, PID, has the same name as the child.PID. Therefore, I must specify the table name. If they did not have the same name, then I would not have to specify the table name. Is that fair enough? Okay. So this is going to give me the same values. Okay. Now, I do want to see the word inner. If you just say from parent as P, from parent join child on parent.pid is equal to child.pid, yes, that would work. In other words, if I were to rewrite this, just show you, I don't have to alias it. If I didn't alias it, I would have to say parent there. If I didn't alias it, I would have to say parent there and parent there. Okay, so parent PID, because I have to say parent because PID here and PID here are the same field names, so I have to specify it. And then child, If I don't alias child, then I have to say child here. I think it's a good idea to alias it child here. Okay. Parent PID as primary key. I do not have to say, I do not have to alias this. I do not have to alias this. I call from parent, inner join child on parent.pid is equal to child.pid. This one would be fine. If you gave me this as an answer, I would be happy as a clam. Don't have a problem with it. So these two are the same. This one, well, you just chose not to alias the tables. Maybe you just like typing. I don't know. If I told you to rename it as primary key and foreign key, then you'd have to do it. This particular one, you did not alias the parent PID, child PID. So when you run it, you see it as PID, PID, CID. I don't see anything particularly wrong with that. I think they should be aliased as, I think the fields should be aliased as something different, but that's fine if you don't. I don't have a big problem with it. Now, here's the problem. Sometimes students will just learn that all they have to write is join. That is true. All you have to write is join, but not in this class. Not in my class, not in my 1309 class. When you get to my advanced class, I'm going to let you just write from parent, join child. Yes, but this one will work. Yes, I agree, it will work. And everybody's going to argue with me, well, but I told you, don't write it that way. You have to write inner join. I-N-N-E-R. Because if you say join, the only thing it could possibly be is an inner join. Therefore, it lets you drop the inner join, but other platforms will not let you be so sloppy. So I will not. Okay. So if you don't choose to alias your tables, I strongly suggest you write it this way. So this is suggested. This is the way I would think that it should be written. This way works. It works. I don't like it because in the output you have two fields named PID, but oh well, you can work that out. Do not drop the inner. If you choose to drop the, do not drop the as. For example, select p.pid space primary key works. In other words, you drop the as, and this will work just fine, names it primary key. But I will not be happy if you do that because the syntax requires the AS. And in this class, we're going to use the full syntax. So if you start dropping stuff, I'm going to send your queries back to you, and my comments on it will be use the full SQL syntax. That means you're dropping the as, or you're dropping the inner from inner join. At least for right now, that's what we've got. Okay. And so I drag all this stuff out here. Property of the inner join. Childless parents. If a parent does not have a child, that parent will not appear in the inner join. If a child is an orphan, The child will not appear in the inner join, i.e. the child has a null parent, does not participate in the relationship. Others that will not be picked up by the inner join would be an invalid child, a child with a parent who was invalid. We should not have that at this point because I haven't given you any way that you could have a child. An example of an invalid child would be, what if I had a child, so the child is named X, Y, and Z. What if I had a child X, a child Y, a child Z, a child W with parent K, but I don't have a parent K? Oh, this is bad. This is very, very bad if that happens. I have an invalid parent. That should never happen. That should be blocked by the database. But what if it weren't? What if somehow it slipped in there and I have an invalid parent? And yes, in fact, you do have a couple of invalid parents in your database, because I put them there. It's possible. It's supposed to stop you. It is supposed to stop you. That is why a foreign key, you say it's a foreign key, references parent PID. You're not supposed to ever get an invalid parent in there, but I can make it happen if I really want to badly enough. And I did a couple of times. So invalid parents will not show up in an inner join either. So the only thing that will show up in an inner join is places where the primary key is equal to the foreign key will show up. So number 1 will show up, number 2 will show up, and number 6 will show up. So anybody that does not have a child will not show up. Any child that does not have a parent will not show up. And a child with an invalid parent will not show up. Okay, that's an inner join. Well, let's move on. 6, they're not doing too bad. Oh, goodness. Slides, okay. Okay, this is the modern syntax. This is the one. Select, and there you have the fields from parent as P, inner join child as C, and you can have more than 2. There's nothing special about 2. Return all vendor name, invoice number, pairs, 114 rows. I think I did it. Okay, here it is. Written using inner join, so you should try that. Here it is. Select invoice number, comma, vendor name. You don't have to specify the table on any of these. If you did, it would not have been wrong. So you could have said invoices.invoice number, vendors.vendor name would have been perfectly okay. From invoices, and I like to rename them here on the from line. I say from invoices as I, inner join vendors as V, on I.vendor ID is equal to, because I don't like typing. Let me pull this over into mine. Copy. Okay. Since I'm using a different database, I have to use AP_DB because I'm in the new. If I don't put that in there, it isn't going to work. And there we paste. So select the invoice number, vendor name from invoices as I. Here I will usually tab over inner join. Well, maybe not. It's what I want. Usually I will do it like that. Your choice. You make your call. Get you a syntax. Get you a format that you like. I'll be okay with it if you're paying some attention to it. So in this case, I want to see all of the invoice numbers, vendor names, pairs, invoices as I, inner join vendors as V, on these guys. On vendor ID is equal to vendor ID. And so I'm going to have to execute that first. So I execute, and here I have 113 rows, and I have all of these vendor invoice numbers, the vendor name IBM, IBM, Blue Cross, Blue Cross, Blue Cross. Notice I'm getting some duplicates here. That's fine. Lots of things from Federal Express, whole bunch of them. You know, got a lot of vendor names that don't have any invoices, but that'll be fine. You can have a where in there, so if you want to only select certain names, if you want to select only certain states or only certain cities, that's fine. You can do that. Where the vendor city is Fresno, in that case it would be fine. It would limit it only to that. Order by any way you want it ordered. And notice that the syntax of the join of the new syntax of the join does not need a where clause. Okay, so if we only wanted California, that would go a where clause and order by. We're skipping pages. Some stuff I'm not sure why I skipped those pages. Skipping pages 132, 133 as being an excessively obscure example. Table may be joined with itself. I'm going to pause here for a minute before I go into a self-join. If you have a question, you may send it via chat, or you may unmute. I'm going to pause a second. I'm going to grab a quick drink of water. I'm going to pause my recording, and I'm going to grab a quick drink of water. Okay, recording is resumed. Okay, a table may be joined with itself, and this is covered on pages 134 and 135. The textbook example is, okay. Find vendor names that share a city in common with other vendors. Most often found in a table where the foreign key references the same table. Now, this particular one is, this example is, has a table named employees. Employees has a table called EID is the primary key. I don't think, I should have written down that table. Okay, I guess I'll use the textbook's example. Find vendor names that share a city in common with other vendors. Okay, so vendor names that share a city in common with other vendors. How will I do that? Well, let's go over here to do it. Okay, select vendor name. Vendor name as, now I need to rename this, so I'm going to say VN1, vendor name 1. vendor name as VN2. So I'm going to have to rename them because they have the same field name. So I want them to be common. From vendors, inner join, vendors, inner join vendors. Oops. I'm going to have to rename these two tables. So I'm going to have to rename them. I can't have two tables named the same. So I'm going to have to rename one of them. Might as well rename both of them as, I'm going to call this V1. And I'll call this one V2. On V1 dot vendor city is equal to V2 dot VENDOR vendor city. Now that's supposed to, I guess, supposed to go away. Why is this ambiguous? So I have to say, I have to choose. See, vendor name is in both of these fields, so I have to choose one of them. It really doesn't matter which one, so I'm going to say v1.vendorName, and then I can just say v1.vendorName again is fine, because I have to choose. It won't choose for me. And so if I stop right there, I'm going to see all of the pairs that live in the same city. Now let's take a look at our output. Oh my goodness, look at all of this output. Let's see, let me pick a couple, let me pick something simple here. Because one that I just have a couple in. I have 1,896 rows. And I'm going, oh, this is just kind of a mess. Okay. Notice that United Parcel Service is in the same city as United. I got a feeling I would have some others with UPS in there. I'm going to throw an order by in here to get rid of some of this stuff. So I'm going to throw in an order by. Let's order by v1.vendorName. Okay, that got everything together, at least together. I need one that's got just a few. Okay, what about AT&T? Well, AT&T is in the I don't need to see vendor name. I want to see vendor name, comma, V1 dot. I want to show this problem. Vendor1 dot vendor city. And let's see what we have here. So whether they share a common city, Fresno, 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 American booksellers. My point being here is that if I want to place people who share a common city, I share a common city with myself. So I am going to show up twice in here as one. I will show up as vendor name 1, and then I will show up again as vendor name 2. And so I'm going to see lots of duplicates because I'm going to show up as in both places. So for example, this particular one here, the Bertelsmann Industries in Valencia, shares a common city with Bertelsmann Industries in Valencia. And that's just, there's only one of them there's only one entry, but it shares a common city with itself. Okay, so in order to fix that problem, anytime I'm into that one, I don't know whether I should have gotten into this or not, I can fix it by on vendor city, I put a where in there, where v1 dot vendor city is less than v2 dot vendor, and I mistyped that. Put a dot in there, where v1 dot vendor city is less than v2 dot vendor city, and this will eliminate the duplicates. So now when I execute this, excuse me, vendor name. So when I say where vendor name is less than, now I've got it down to 887 rows. So now I only have those guys that actually really share the same city. Now, if I put something in there that would let me identify them, so vendor ID instead of vendor name, if I had set that down to vendor ID, vendor ID on vendors where vendor cities are the same. Vendor ID is less than the vendor ID. Order by vendor ID. Now I should be able to see now that I have gotten rid of a lot of the duplicates. So that's not showing that real well. I'm gonna put that away because I don't feel like getting bogged down into this any further. This is the one, textbook example, okay. This particular one, I think I will probably do this on Tuesday. Think of a table join as almost always following a foreign key to its primary key parent, and you'll be pretty good shape. Next. Multiple table joins. There's nothing that says that this is limited to 2 tables. I can have a parent and a child and a grandchild in this case. So one parent has many children. One child has many, in this case, toys, grandchildren. And I can follow it as many levels as I want to. So it's not at all unusual to see table joins going through 3 and 4 tables. Enter join review. This class inner join is following a foreign key to its primary key foreign key link. A foreign key only ensures that the primary key appears in the parent table, i.e. it will stop any bogus parent keys. A foreign key may be null. They're called orphans. In an inner join, only records that participate in the relationship will appear in the output. Parent records without children will not appear. Orphans or null foreign keys will not appear. And there's and invalid children will not appear. Only those that participate will appear. Here's the assignment. And we've done this one, write an SQL select statement. And I say using the explicit join syntax, what do I mean? I mean, it says inner join. I think I tell you to, so use the explicit syntax. That's the new syntax. That's the one that says inner join. Oh, number 3, I ask you to do the same with the implicit. I think number 3 is the only one that I tell you to do the implicit. This particular exercise only has 1, 2, 3, 4, 5, and it's worth 20 points. The next one that we're going to do is what we call an outer join. An outer join is one that shows all records. Are there any questions? I wish I hadn't gotten bogged down in that example of a table joined to itself. I think I'll probably take that out. I don't think I have any in here. This, no. Implicit join, no. Return 3 columns, no. This one has 3 tables in it, but I do not have any examples in the assignment that require you to do a table joined with itself. So that'll be okay. Questions? I'm going to pause here and you may unmute if you wish, or you may send me a text. If there are no questions, I'm about to end the recording. I'm pausing the recording.